Okay, number 20. The height of an apple after being tossed from a building is modeled by the function h of t equals negative 16t squared plus 48t plus 54, where h represents the height in feet and t represents the time in seconds. So if t is an input in this function, it's where x normally is. That means t, or time, is going to be on the x-axis, and height is going to be on the y-axis. So part A asks, what does the 54 represent in the equation? Well, if I'm looking at the graph, I have it graphed on the right side over here. And I'm looking at where the graph touches the y-axis. I notice at that point is 0, 54. So for h of t, if we are looking for h of 0, or what the height is when time is 0, so when we started, what's the height? Negative 16 times 0 squared plus 48 times 0 plus 54. Well, this first term goes off to 0 because 0 times anything is 0. And same thing for the second term. So h of 0 is 54. So that means that my starting height has to be 54 feet. So you could say that the building is 54 feet tall. I'm going to say that 54 represents the starting height. So when you toss the apple, it starts at 54 feet, goes up a little bit, then it comes down. So how long does it take for the apple to reach its max height? Well, if I'm looking at my graph here, I'm going to need to find the vertex, or that top point. And I notice that the vertex is 1.5, 90. So I need to ask myself, which one of these values represents how long it takes? And remember that we said that t is going to be on the x-axis, so I'm looking at that 1.5, or my x value there. So it takes 1.5 seconds for it to reach its max height. Similarly, since the height is on the y-axis here, that 90 represents the max height. For part D, how long does it take for the apple to hit the ground after being tossed? So if I'm standing on a building and I toss something, comes up, comes up, comes up, comes up, hits the ground. When it hits the ground, your height is 0. So you're looking for a point on the graph that represents the height is 0. And remember, the height represents the y values, so we're really looking for when y equals 0, or the x-intercepts. So if I go down, I notice that at this point right here, 3.872, 0, the apple stopped moving and it hits the ground. So if it's asking for how long, again, I'm looking at the x value, and it says round to the nearest hundredth. So I would say 3.87 seconds. Okay. Number 21. Solve by substitution. So in order for us to solve by substitution, we need one of the equations to be equal to just either y equals or x equals first, so we could plug it back into the other equation. So I'm looking at this second equation, this linear equation right here, and I'm noticing it might be a little bit easier to get one of the variables alone here rather than use the circle equation above. So I'm going to subtract x on both sides to get y equals negative x plus 6. You could write it as 6 minus x. I'm just going to put the x term in front. And what we want to do is we want to take this y value and plug it in for that y right there. So I take my second equation, x squared plus, instead of y now, I'm going to write negative x plus 6 equals 36. So I have a binomial squared. I need to write it twice and distribute. So I write negative x plus 6 times negative x plus 6 equals 36. And I distribute how I normally do. Negative x times negative x is a positive x squared. Negative x times 6 is negative 6x. Negative 6x. And 6 times 6 is 36. So I'm going to keep going up here. Now I notice I've got some like terms I can combine. This x squared and this x squared makes 2x squared. And this negative 6x and negative 6x can be negative 12x plus 36 equals 36. Now if I try to get this quadratic equal to 0 by subtracting 36 on both sides, it ends up canceling on both sides. And I get 2x squared minus 12x equals 0. So if you wanted to solve this quadratic using the quadratic equation, you could, but your c value would have to be 0. So instead, I'm going to factor. I notice they have a 2x as a greatest common factor. Then I'd be left with x minus 6 equals 0. So from here, I set 2x equal to 0, and I set x minus 6 equal to 0. When I add 6 on both sides, I get x equals 6, and when I divide by 2, I get x equals 0. So I have my two solutions for x. I'm going to plug them back into one of my equations to solve for y. It looks like this equation that y equals negative x plus 6 might be a little bit easier to work with. So I'm going to take y, and instead of x, I'm going to plug in 0 first to get 6 for y. And instead of x, I'm going to plug in 6 and get 0 for y. So my two solutions, if I'm writing them as a coordinate pair, I've got these y values and I've got these x values right here. I'm going to write them as a coordinate pair of x comma y and x comma y. So when I plugged in 0 for x, I got 6 for y. And when I plugged in 6 for x, I got 0 for y. So those would be my solutions to this system of equations. Now, if I'm trying to sketch a picture of what this looks like, I know the first equation is some sort of circle, and I know the second equation, based off of me solving for x right here, is some sort of line with a negative slope. So if I go to my graph, here I've graphed both functions. This green circle represents the x squared plus y squared equals 36. It's a circle centered at the origin with a radius of 6, and the orange line represents the y plus x equals 6. If I'm looking at the points of intersection, the 0, 6 and the 6, 0, those correspond with the two solutions I got when I solved algebraically. So the picture looks just something like what I had there. A circle with a line that intersects it at 2 points. Now, if you notice for 22, this is no longer a line and a circle. It looks like the bottom equation is a circle, but that second equation looks like another quadratic that we've been working with. But the process still works the same way. I can take this value for y and substitute it in for that y right there. So I write x squared plus, instead of y, I'm going to write x squared plus 5 equals 25. And I have a binomial squared, so I'm going to need to distribute again. So I write it twice, x squared plus 5 times x squared plus 5 equals 25. And x squared times x squared is x to the 4th. X squared times 5 is 5x squared plus 5x squared plus 25 equals 25. And I bring down that x squared from before. If I'm combining like terms here, I notice I have 1, 5, 5x squared. So together that makes 11x squared. I still have my x to the 4th term plus 25 equals 25. Now the same thing happens when we subtract 25 on both sides here. It cancels on both sides, and we're just left with x to the 4th plus 11x squared equals 0. So it's an x to the 4th, so probably using the quadratic formula won't help me too much here. So I'm going to factor again. They both have an x squared in common we could pull out. And we're left with x squared plus 11 equals 0. I do the same thing where I set both of them equal to 0. So when I take the square root on both sides, I get x is equal to 0. And for my second equation, when I set it equal to 0, I get an equation that says x squared equals negative 11. Now you need to ask yourself, what number can you square to get a negative number? Well, a negative times a negative is a positive number, and a positive times a positive is another positive number. So right now, we don't have any way to solve this equation, so we can reject that solution. So there's actually only one point of intersection for these two graphs. So we could take that x value and plug it back into one of our original equations to figure out what that y value is. So the point of intersection here for these graphs is 0, 5. What this looks like is a parabola just sitting right on top of a circle. So something just like that.